So what I'm going to talk about today is my just some reflections on trying to teach evidence-based design in studio at Lincoln University. But really, we've been, or I've been working on this since I got here. But this, most of these lessons come from the past 3 years when I've been teaching one design project over 3 years, which is actually based on Anna Priya's work. So I'll get to that in a minute. But really, we need to go back and, I started thinking about this way back when I was learning from Bob. So a lot of this stuff is really based on Bob's work of the past and Rob Corey and Leanne Milburn and Sonda and others who have been pioneers in trying to promote this type of design. So anyway, without further ado, I'll just start the process. So basically, it comes down to us at the moment having very serious high-risk problems in the world. And most of these are caused by landscape change from people all over the world manipulating and changing their environment. Now, landscape architects aren't responsible for it all, but we should be providing leadership to ensure that whatever we design, and when we talk about design with clients and others around the world, that we're that we are basing our designs on factual evidence so that we are not contributing to these problems and in fact are trying to come up with solutions. So, so that we can contain some of these huge problems within this green circle you see here, which is kind of like the limits of what we should be doing, in terms of addressing these problems. So this is kind of, I just downloaded this design from the internet. It's in Anguilla, but it's kind of typical of what my students do. So they kind of say things like, oh, it's an ecological park, it's sustainable, it's resilient. They use all these words. And they say to me stuff like letting nature create nature and this gradual transition from nature, which I guess is kind of wild, to an artificial environment. So I get this kind of stuff all the time, but when I look at their designs, so you kind of look at the bottom right photo, if you know anything about ecology, you look at that and you think that's going to lead to that water body there being polluted. There's no vegetation on the edge to filter any of the residue coming off that land, which is very green and consistent. So they might have to use fertilizers, etc. They don't have any trees to cool the water. There's a kind of a homogeneous bed of flowers there with very low diversity. And chances are they might just rip the whole thing out and put in new annuals to make it look pretty. So it looks like it's green and healthy, but it's really just green sheen, and so that's really what we want to avoid our students creating. We need innovative but real design solutions, one that address the problem. But right now I think we're like that little black cat there pretending it's this big lion, that we are these leaders of healthy environment design. And in fact, we're not. So that's the kind of thing we want to avoid. So we want to base our designs not just on our beliefs and wishful thinking, which is, I think, what we're doing right now. We're kind of thinking if we use words like sustainability, et cetera, that it's actually happening on the page, but it isn't. So we want this evidence-based landscape architecture design, and this idea of evidence-based design, is being used by other professions also. But Brown and Corey came up with a definition for it in 2011, the deliberate and explicit use of scholarly evidence in making decisions about the use and shaping of land. And this was then built upon a bit later around the same time too of practice-based monitoring and performance assessment. So it's kind of like a two-step process of before the design is implemented, you have kind of a hypothesis, a design hypothesis based on scholarly evidence. After it's implemented, then you have practice-based monitoring assessment to determine whether it meets its goals and objectives. And then the process begins again with, again, looking at scholarly evidence as we move through time. And it's kind of more of like a circular process within the landscape that's being offered. But what we're going to do is look at just the first part of this because we just teach our students mostly design hypotheses. We don't go out and test and monitor things, at least in the studio. We don't generally do that. Okay, so this is, I don't know if you can understand this, but the top part of this diagram shows what I learned when I was in my BLA, the process. So this was before evidence-based design. There was usually, you were given a design brief that was pretty general, and based on reading that brief, you came up with your objectives, and they could have varied. Different students came up with different ones. A lot of students came up with multiple objectives because they were thinking big. So it was sustainable this and clean water that and a whole bunch of things. And then we would go out in the field and do an inventory. And generally speaking, it was pretty open. So it was kind of the attitude when I was in school was try to be very broad about it so you don't miss anything. So it was inventorying pretty well biophysical characteristics of all kinds, whatever you saw, and then sociocultural things as well. And then you tried to sort that all out and come up, maybe revise your objectives to be more specific to the site. And then you hit on this very more extensive design process and came up with a design. There wasn't any evaluation or anything usually done. And they were very short projects. So you might have had 3 studio, different ones through the 12 weeks of a semester. So they were kind of very short and sweet, but they look kind of like that. Then we hit this evidence-based design process, which Milburn and Brown developed in 2003. And that tried to weave creativity with research, which is one of the main criticisms of, I would say, evidence-based landscape architecture, that, where does the artistic happen? And if we put in too much research, all of a sudden that, new innovation and creativity may be lost. So this was a good thought about how to weave the two together. And you'll see that there's kind of an equal segmentation of 3 phases. So you have the first, which is the research phase, and then the second, which is more concept of exploration, I would call design. And then you have design assessment before you get to the final solution. So it kind of extends the process. But you can see that that there's kind of, I would say the research phase in this particular diagram is a bit more compressed. So the conceptualization is that it would take a little less time in the studio than maybe the design and evaluation side. So still you have the design phase is really dominant in this model, if that was the intent behind it. Bob can comment on it later. So that's the idea of design as a hypothesis. That's, based on scholarly research, we're going to come up with a design that meets what the theory says, our spatial design will meet. So that's great. Then in the last part, you have this idea of extending this to the monitoring and testing point. So we're not getting into that bit, but that's the next phase. Beyond hypothesis is, does it really work or not? And that's a really important thing we need to address as well. but the check mark, it means that that's really not what we're talking about in a studio. But somehow we got to bring that together and teach our students that next phase, because otherwise, of course, they're going to go out, become practitioners and not do it. So how that's going to work, I don't know. I think that's a kind of a future move. So what did we do? So this is my studio. It's a third year, mostly undergraduates, although in the last year, we've altered our master's program, and now we have master students in the same studio. So we have one group of master students, maybe, you know, a handful full, and then you got about 25 undergrads. And what we did was we did an adapted approach of research through design methodology, which Sanda developed. So Dr. Lenzholzer, if that's how you pronounce her name, in 2013. And she was looking at really this, how do we weave research into design process? Is design research? It's that whole question, but it's the use of that kind of model to try to incorporate research into the process. So she talked about the production of empirical evidence-based generalizable specialist knowledge through the process of design. So how do we use that? And then Sanda and Bob used that process to teach kind of two different, well, one studio in two different countries on responsive landscape architecture design to climate, so climate responsive. So we kind of used that model, and we did it over 12 weeks. Now, when we started it, it was only 8 weeks, but we found it wasn't long enough. So we extended it over to 12. So this is what we did in the end. We had 4 stages. Each stage has an output. So the first one, review and summarize the evidential theory. That's in the research phase. That was output 1. Then we had the inventory and analysis phase it was also part of the research. That was output 2. And output 2 was compared with the output of 1. So it's an integrated approach. So the inventory and analysis was compared with the scientific literature. So it was that idea of to what extent does the site meet the scientific literature the way it is designed currently. Then we had phase 3, which is developing the alternative design solutions. And again, here we're comparing the design solution to outputs 1 and 2. So it's kind of a circular process through it. And then finally, so that comes up with the design. And then the 4th stage was evaluating that design that they had chosen with the existing design. So that's comparing it to outputs 2 and 3. Well, the designs compared with the inventory and analysis. So you have this compare before and after. So I'll show you how that worked. So the first stage was the literature review stage. And this is what we found, that the students had trouble finding quality and relevant scientific literature that was applicable to the spatial design. So, and here's what we thought, the barriers that we uncovered. And they know little about the problem or the solutions coming into the studio. And, this is an interesting point, because it's something that I never really thought about the significance of that before. And often, to tell you the truth, I have also started studio projects knowing very little in-depth information about it. And I think that's very common in studios. We often take on projects all the time. My colleagues do it all the time of, maybe a community contacts the school and says, will you take on our project? And someone says, okay, yeah, I'll do that. And no one knows much about it. right? About the problem, about the solution. So, you know, I really got a good appreciation of what students must go through when they land in the studio and know nothing about it. And if you think about other fields, they don't just give someone, go out and do an essay on a topic. Like they don't, you know, ask them to solve a whole bunch of problems and not teach them any theory to begin with, right? So that was a problem. And then we had too many vague design goals. So that's what I picked up from previous studios, but you've got to be specific and you have to really deal with one design goal. You can't have a whole bunch and have different students working on different goals. They really have difficulty identifying specific and relevant design objectives. So the things you got to solve in order to meet the goal, they have trouble defining those in meaningful ways. They tend to be vague. So maybe they talk about sustainable this and, you know, resilient that without really defining what do they mean by that. And you have to be specific to find good literature on a topic. They don't know how to do a critical literature review. And this is something Bob and I found a long time ago. You know, they don't know the difference between different types of material they might find on the internet. They don't know how to be critical when they look at it. A lot of scientific papers don't provide evidence that's spatial. It might just be text or numbers, and the students don't know what to do with it. And when they look at their piece of paper or their design, it's not in the form that they need to act. Evidence is sometimes missing that they need, or it's at the wrong spatial scale. And then also we found that we haven't dedicated enough time to allow them to do this, given all these barriers. So that's what we found in the first stage. So what we did over this 3-year period, we did this kind of incrementally. We made sure that we only took on design problems in which we had expertise. So Anna Priya provided this fantastic expertise, and she got them started, which is another thing that we decided to do, kind of give them a leg up. So we gave them an expert lecture. Anna Priya came in. She put in a kind of a 3 or 4 page brief of kind of summarizing in general the literature, provided them some references to get them going. So we did that. We provided them with a specific goal, so we didn't allow them to do that. We talked to them about key variables that would determine the goal, and we taught them how to organize the variables hierarchically. So we started using little memo pads and the wall and kind of stuck them on the wall to say how were things linked together. Which was important for them to understand how the thing worked. We taught them how to do a critical lit review. We taught them a tool for providing evidence when it was missing. So they actually had a little unit in the computer lab to teach them Google SketchUp, 3D modeling. So they're able to see, for example, the shade. And when they changed their design, they were able to see the impact of that and what it looked like on the ground. And sometimes they would try to find evidence about an element, say in the schoolyard for this example, and they couldn't find it. So creating their own was an important part of the process. We also got them to, as the product, to create design guidelines. So it allowed them to translate literature into spatial form in a very practical way, which was directed towards practitioners. So they actually had to come up with a document that showed how it was done, provided the evidence at 3 spatial scales. So we did it at the element scale, like a tree. We did it by schoolyard activity area, which is the scale at which children make decisions about where they go. And we did it across the schoolyard. We taught them what an effective design guideline criteria was, and we used that for grading the output. So we actually, so that they knew exactly how to put one together and were motivated to cover the criteria and do a good job. And then we gave them more time. So we gave them 1 month to do this. And this is what they came up with. So this is just an example of a table of contents. So it covers all the different aspects. They had an initial section on understanding sun and shade, its importance, the problem, skin cancer, etc. Goals and objectives of the document, who the guidelines are for, how to use them if you're a practitioner. Further information was just more, probably more theory about it, the different things that affect sun protection behavior. Then there were different sections. So here's one on direct UV, natural shade, and then they did single trees and how the canopy was related to shade and using multiple trees and shelter belts, etc. So all these things were covered. And they did it in the 3 spatial scales. And here's an example of one of the pages. So this one just deals with natural shade, direct UV. It's got the scale here in the corner. It's the component scale. So they're using symbols to help practitioners find the information they need really quickly. It's got the design objective up here so that a designer can say, is this my objective before reading it? And you can see how it's quite simple, and it's using that modeling to really clearly show the difference between doing it right and kind of doing it wrong. And this was really effective for showing them the impact of these different elements in really making a difference in their schoolyard. And once they got this in place, they're really able to use this tool very easily when they're moving into the design phase. So stage 2, the inventory and analysis. Students had difficulty identifying the specific design objectives from the variables. So that was, we had to work with them on that. So they now have to come up with a design objective for their design. Which they would then use to compare the first stage, which is the kind of the toolkit, with what they're trying to achieve in order to analyze their inventory. So that we had to work with them a bit on that. They often didn't know how to identify what inventory elements to look for. So we had to, I'll show you how we handled that one, but we had to work with them that too. They weren't sure what to look for when we went to the site. So that was one thing. The 3D modeling, it didn't help them to determine when the site components met the design objectives. So it could show them the shade, but they weren't able to use that to determine when enough shade had been provided, right? So when was there enough shade and when was there too little, which is what you need to know to make a design decision. It also didn't help them see where all 3 variables were in place. So the modeling didn't show where they needed to have microclimate, objectives met, shading, direct and indirect met, and a good activity to attract children. All 3 had to be in place to support behavior, but the modeling didn't show that. It was quite, it only showed some variables singular in place. So that wasn't so good. Again, they lacked sufficient time. So again, we extended that one to a month. So it was another period of time, or at least 3 weeks or something like that. We had to extend it to allow them to do the analysis. It's really, you know, as I said previously, and Bob and I noted this a long time ago, is students tend to stop at the inventory and they never say what it means in terms of how they're going to solve the problem. So this is what we did about it. We taught them how to develop specific and spatially relevant design objectives from the goal. We gave them this little chart, so they had to relate the goal with the objectives to make sure the objectives met the goal and identify inventory for meeting each objective, which allowed them to help organize themselves and really directed them as to what they needed to do. We worked with them to develop targets. So we said, okay, how much shade is needed for a sandbox? So that should be 100% cover because it's a small area and the kids are sitting there inactive for a long period of time. What should an active field be? Maybe it can only be 30% because the area is large. So we had to kind of work with them to develop the targets. And then we introduced the landscape unit method for showing how multiple variables could be in place in the same activity area. So they could see where one was missing or two or what was going on in order to make design decisions. So we did that. And then this is really what we came up with. Most of them didn't do the unit analysis. They stuck with the modeling. And when you do the modeling, you can see how they divided it down into the different objectives, but they're all individually communicated. Okay, so the microclimate ones on this side, but they did a great job of showing how it worked, and they played with different times of the year and showed how the change occurred, and they could really see where the shading was in place and where it was missing. And you know, they looked at different materials, etc. So, and you can see there's the, you got the background, the vision, the objectives. They connected the inventory, which was really nice to see. They did some really great modeling, but it doesn't bring it all together in terms of behavior. It's better for showing how the site meets individual design objectives. This is one of the master's students, so they were able to go further. So this shows how we use the unit approach that we introduced them to, but we had to really teach this, and I had to reinforce it in my landscape ecology course. We often do a project where they have to locate a wetland on campus by using this layering. So this would have been the second time they used the approach, but most students at the undergraduate level found this difficult to do. But the master students did a good job, but it was done, you know, it wasn't done across the schoolyard. So it was difficult, except for the top students had a difficult, but you can see how it works quite well. And this is at the scale of the activity area. So this is a play field. Okay, so for the design phase, so now we hit the design phase. Some of the students had trouble shifting to creative ways of thinking and innovation. I think they just spent so much time on the technical side of their brains that it was hard for them to shift. And then some of them, as Bob knows, because he's done work on this, are just more oriented to the technical aspects and analysis, and they just had trouble loosening up and shifting to more creative ways, which is this stage is where they really need to get creative, kind of stand back from the technical stuff and start thinking outside the box and dealing with these other issues that we have to deal with design, especially in this project, coming up with new activities for the kids to do. So that was tough for some of them, and they kind of stalled a bit at this stage. Okay, so, but at this stage, they were able to, some of the students just looked for kind of holes in the existing design and tried to fill them. So where there was shading missing or an activity missing. Others just redesigned the whole schoolyard and took off things that were doing good on shade, but maybe they wanted to put something else in place. But they were able to bring it all together and still do all their analysis for shading, etc. They just went the extra mile, which was really nice to see. They weren't daunted by, you know, having to redesign the whole site. They just went for it, but they had the tools to do the job. So that was really good to see. What we did for this one is we did some of Bob's creative exercises. So you'll see this one, Bob. So we did a few of these. We did probably over 2 weeks. We did 2 exercises at the beginning of one lecture, one session per week. I don't think it was enough, but anyway, so we tried to kind of loosen them up and tried to get them thinking outside the box, thinking like a child. They worked in groups. I often brought in baskets of weird doodads and springs and all sorts of strange things for them to play with and come up with new ideas. So we did that. And this is the end result for one student. So compared to the original design, which looks more like a prison, as one of Anna Priya, when she was giving her presentation, one of you said that, you know, these schools look like prison camps or whatever. They do. Often they're just like play fields. So here you can see how this student was really able to bring in the creativity, but also able to bring other aspects in as well, as you'll see in a minute. So at the bottom there, you see how they played with different things to provide shade in an interesting way, and really did a good job. So the last stage, evaluation, it needs time and a grade dedicated to it or it won't happen. So at first we tried to put it with the third stage, but in the end, a lot of them didn't do it. So we had to split it off and make it a special phase where they forced them to do it. And we attached a grade to it. But once we didn't find that, and they didn't find it was a very onerous thing because they already had done all the modeling in the inventory and analysis, and they designed in the 3D modeling. So they already pretty well had it done. They just had to put it together. So that's what they did for the fourth stage. So this is the before on the left here, and here's the after. And then they did all the different ways of how their new design met their objectives on the right. So you can see clearly here how the shading was improved. So the conclusions, the 4 phases with interrelated outputs, you know, one building on the next, worked well, but we found the devil's in the details. So there's many barriers and skills they require to do it. So it's not, at first when I was prior to the studio, I just introduced the process and said, go and do it, right? Go and do your lit review. Get it done, and I want to see a design based on it. Well, it doesn't work. You need to address all these things in order to make sure it happens. We found the tools for them creating the evidence was critical. So it really helped to, I think, improve their appreciation for evidence. So because they could see it and they created it themselves. It's a relatively long design process, and we had to do the same studio project for 2 or 3 years to refine it and to learn all these lessons. The teaching's intensive. It's not just desk crits, which a lot of studios rely on, you know, having the external consultants come in. They come in with no background and they just start and they, you know, and go up to a student and try to say something reasonable about their design. That's challenging because we don't pay consultants to learn about these specialized topics. And so there was a bit of friction with me having to make all the decisions and then some conflicting advice because they didn't know what they were doing. So they would critique one student and they would give them advice, and then I'd say, no, that's not right. And so that's challenging, and that's going to have to be resolved. The process caters to specialists, not generalist designers and teachers. So it got me thinking about what it says about landscape architecture profession, where we're taking on a whole variety of projects for which we know little about. So, that's something to think about, that really, you need to be a specialist in order to give the guidance and teaching needed to guide the whole thing. It caters more to master's students than undergrads. It's a little bit complicated. It's quite demanding. And so, the poor students, the less experienced, their brains aren't as, developed, they're going to struggle with this a bit unless we keep it simple and maybe have more limited learning outcomes. The other thing that I concluded, which was surprising, with the teaching process, research through design also led to research outputs. And I wasn't expecting that. We didn't start the process, wanting to progress Anna-Priya's research, but in fact it did. So it got me thinking that actually there is such a thing as research through design. It's not just wishful thinking, and that was surprising. So next steps is to simplify the process for undergrads. Should we have fewer variables or not use the landscape unit method, maybe just focus on the modeling? We need more time devoted to creativity skills and making the process a bit more fun. I think it was a bit intense and hard work and not enough fun, which is expected, especially when they come from other studios, which they have fun generating all these ideas with no evidence. So is the method generalizable to other projects and at other scales? So we're not sure yet. We need other visualization or evidence creation tools. I don't think the modeling is good for some things, but other problems is not as useful. To what extent does the landscape unit method apply to other problems? Is yet to be seen. I think it does have wide application, but it may not apply to different scales. I'm not sure. It could be too complicated. Might just be good for the site scale. Because when you get up to the coarser scale, you start to get into GIS and landscape planning. And I'm not sure it says easy to, for our students to learn from. And then what are the implications for research through design? What new information can be created through design or through teaching design, I guess, in this case? So I have one colleague who says that this research through design, the purpose is to identify a range of possibilities versus identifying the best one. So for his the way he does it, that's his output. That's what he says the new information is a full range of opportunities, which I think is quite typical of what we think of as the way conventional design is defined. But what we found is it developed new methodologies for evaluating design in this case. It also led to improved design hypotheses based on evidence. So moving forward, what are the key aspects of the design that need to be improved, and it would lead to new improved hypotheses upon which to implement the design. So that's about it. So I'm hopefully we've still got time for a discussion. I'm going to stop sharing now.